Hello, college algebra student. This video is for chapter 3.3 part 2. In part 1 we review what is average rate of change, and we see that if we have 2 points, we can actually find the slope of the 2 points. Even if they are not aligned, we can still find the slope, and we call it AROC, and it tells us whether it is the line that connect them are positive or negative, whether it is increasing during that 2 interval or decreasing. So we're going to use that information to study something called describing the behavior of a graph. Because except when a graph is aligned, where it would be changing constantly, either going up or going down. If the graph is not a line, it would fluctuate, right? Sometimes it's increasing, sometimes it's decreasing, it drops and rise and drops. So how do I tell people at what interval it is increasing? How do I tell people about the behavior? So there's several aspects that we can relate to if we have a graph, which is to tell people at what x interval. So at which x interval, like in this case, you can see this graph is going up and down. But we will, in order to describe it, what we can do is when x is here, right, since it's -2, beyond -2, all the way from -infinity is always increasing, because when we're describing them, we look at the graph from left to right. We are actually kind of like traveling around the graph, and think of this as like driving a car, and then you just go up. This is going up the hill. Remember, it is always from left to right. So it is increasing. And you can also think of, if I am to draw 2 points, I have 2 points and I connect them, what is the slope? The slope is a positive slope, right? Positive slope. So this is the positive slope is increasing. So we'll say increasing in this interval, the blue one. And then also from here to here, from x equal to 2, all the way to infinity is also increasing. So we will describe using the x interval. So we'll say from -infinity to -2, and then from 2 to infinity, this is also increasing. So just imagine there's a car driving along this road, you're going uphill, also from left to right. And then what about from -2 to 2? If you imagine you traveling on the road, then you're going down, right? You're going downhill. So we call it a decreasing interval. And this would be in this, you would be describing this graph is decreasing from x equal to -2 to x equal to 2. We call it decreasing. This is increasing, and decreasing. And there's two also other concept is called local maximum and local minimum. In a nutshell, what is a local maximum? I have a local maximum over there, 1 point. So the local maximum is like a small valley. Oh no, actually a small mountain top. So you can think of you standing over here on your left side. Things are increasing, and now you are going to decrease. Okay, so on one side, on the left side, you are increasing, and then you are about to decrease. So this is called the local maximum. Locally, you are at the highest point. Why do we call it local? Because it's not the highest of the whole curve. So see, at the end, when you are going beyond -2, beyond 2, you will be going higher and higher here, right? So all these points will be greater than whatever that you have. That is 16. That's 16. So, but anyway, at this point, the neighborhood, or all the points in this neighborhood is lower than it. Okay, so that's why it's called the local maximum. And then contrary, in the valley, you have a small valley. At the left hand side, the graph is decreasing, but that hope is here because after you pass through this valley, which is the lowest point, in this small neighborhood, not the whole thing, but in the neighborhood, it's going to rise. So we call this the local min, local minimum. Okay, and then the illustration is here. So if you go like this is the so this is also a local minimum. Okay, and then there is one more term called absolute max and absolute mean. Absolute max is absolutely in the whole graph. Now there's two types of graphs. This graph is stop at the end, so we can actually tell where y would be eventually because it stopped. So in terms of the whole graph, on points, all the points here, y would just be between this. So the highest y is 2. The lowest y is -2. So we say the absolute maximum is at x is equal to 2, y is 2. The absolute means out of the whole thing. On this graph, there is no absolute max and min because it's going to go to infinity on one side, more and more, and it's going to go down to infinity. So absolute max and min does not necessarily exist. You have to graph the function to see if it exists or not. So a few concepts: increasing interval, decreasing interval, local max, local mean, absolute max, absolute mean. Let's do two examples. Example 1. So I have a graph of a function here. I want to find the interval of increasing, decreasing. So when we say interval, it's always the x interval. Okay. So tell people at where x is going uphill. So obviously this, so you go from left to right. Oh, you are traveling uphill already. And here I'm traveling uphill, but not here. So I will just write down increasing. What is the interval? I go from x is equal to -2.5, I guess. And then it reached here, reached -2. And then also from 0 to 2. Union from 0 to 2. Well, actually, we just go use the open interval because at the point of the highest point is not increasing. And then what about decreasing? So this is still increasing. Decreasing would be when it's dropping, right? So from left to right is dropping in this 2. And if we look at the x value is from -1 to 0. Is it -2? -2. -2 to 0. Union from 2 to 3. 2 to 3. So that's the decreasing interval. What is local max? Local max is what is the small mountain. This is a small mountain, and it is at x equal to -2. Y is 16. And another local max here. So you don't have to compare which one is higher. So long as it is a small mountain, x is equal to 2, y equal to 16. Are there any absolute max? What's the highest point totally? Absolute highest y. Absolute max would be, out of the whole thing, I think 16 is the highest point on this 2 point. So we just need to say y equal to 16. Absolute minimum is the lowest point of the whole graph. Oh, would be this point, right? -10. So in this case, it has all these. Example 2, interval of increasing. Again, so I start from here, but this doesn't stop anywhere, so it goes to infinity. So I just imagine that I'm going from extended, right? I'm driving the car from -infinity, so obviously this is going up, increasing. And then at here it's also increasing. In the middle is decreasing, right? So let's say increasing. Interval is from -infinity all the way to the highest point. I think I would just pretend it's -3, and then from 3 to infinity. 3 to infinity. Decreasing is the middle when it is sloping down, right? Sloping down. So -3 to 3. This is the x interval. So you can say from here, x values, or this x value, it would include this branch. Okay, you don't read the y value, you read the x value. Increasing, decreasing. Now for local max, you look at the y value. Where is there's a small mountain? This one, right? This is a small mountain. So I think it is it 60? Not yet. 50, 55, let's say. Negative x is equal to -3, y equal to 55. We don't have another mountain, we have another valley. So we say this is a local mean. Local mean is x equal to 3. At x equal to 3, y is negative 55. I think it's 55. It's not, or maybe it's 50. Let's say 50 then. And is there any absolutely highest point or lowest point? No, because this would go down all the way. This go down. No absolute max and min. So you learn this again in calculus. So it's kind of introducing those terms. So now we have two functions. So sometimes can we just look at a formula and figure out where is the increasing, decreasing? We'll have to use decimal to graph it. Okay, x4 minus 4x cubed plus 5. So graph y equal to x to 4 minus, is it 4x cubed? Okay, 4x cubed plus 5. Oh, so something like that. Is this is there a valley here? I don't think so. I think it's just drop and then drop down. So if it doesn't, yeah, it doesn't change. So, but then there is a small valley here. It's -22, right? -22. So we just zoom in a little bit. You can say from, so I'm just pretending I'm driving the car, so it's like sloping down, slope a little bit, and then going down again. So in this case, I would say from -infinity to x is equal to 0, and then from 0 to, what is this point? It's from 3. Okay, so we would say decreasing -infinity to 0, and then start from 0 to 3. And then increasing after that from 3 to infinity. Okay, local, we only have a local mean at x equal to 3, y equal to -22. What about t? Oh, I think this is a square root. It is not t plus 3. I forgot the typo. Okay, g of t equal to t square root of t plus 2. Oh, t plus 3. Put off this. Oh, so this is something like that. So it start at this place. So I'm just start from here. So it's going down to -2, and then just shoot up, right? So the down interval would be from -3 to -2. The up interval is from -2 up. So so say decreasing first. Decreasing from -3 to -2, increasing from -2 to infinity. And then what about local? We only have a local mean also, just as a local mean. At x equal to -2, but what is the y value? It is also -2. Y equal to -2. So that is a local mean. I think this is an absolute mean also, right? So this is also an